Hey, what's up, everyone? So, listen, I am actually working on the AMG right now. As you can see, taking off the exhaust, and I'm actually going to do a dump style exhaust up at the front. That being said, while I've got it on the lift and I'm under here, I want to show you guys something, and you'll have to excuse me if it gets a little dark under here. But you'll notice on the AMG and a lot of other cars, these dimples. Now, some of you automotive fanatics will probably recognize those. And if you're an engineering student or anyone who does automotive engineering or any kind of engineering, you've probably argued about this at the bar once or twice with your friends. Here's the question. Do these work? Do these dimples actually work? Now, here's the backstory on these. So in the 30s, golf companies, like the golf balls, like you play golf, they realized that dimpled balls travel farther. They had more lift and they could get a straighter, longer drive out of them. So you would think it stands to reason, okay, the aerodynamics say then that it makes a smoother flow. Well, as time progressed and we got better and better at testing those sort of things, we realized what's going on. So what's actually going on is the air over that surface is going from laminar flow, which is to say like a smooth, good, for all you non-engineering folk, a good smooth flow over the surface, to basically a reeker or turbulent flow. What that causes is the air to actually stay attached to the ball longer. Here's the thing. A golf ball spins. It's a round object that spins through the air. Last I checked, cars don't spin through the air. And if they do, you better hold on. You got a problem. So it's been an ongoing discussion whether these dimples actually make a difference. There's a lot to be said of, do they make a difference with bicycles, the bicycle wheels? I think there's been some companies that have done that, have tested it, and they do help. There's been a lot of tests done for car aerodynamics, and you could say the jury's still out. Truth be told, if there is any kind of advantage, it's a very slight advantage. At most, you're looking at maybe a 1% gain on things like miles per gallon or something like that, which, if you don't know, usually if you get better miles per gallon means you have better aerodynamics. That being said, I'm kind of surprised that Mercedes put this on the car, or that any car manufacturer puts that on. You could say that they did it maybe as a way, because I mean, technically this is kind of a flat bottom car, as you can see. I mean, as much as it's just a regular car can be. It's obviously a lot different than like us making a race car, a true flat bottom car, like a prototype style or something like that. But with these, you could say that, maybe they're being used or being helped somehow, with the back end when the air comes back out and meets back up on the back end with the air that went over the top of the vehicle. But that's kind of doubtful. I mean, I've built a lot of these things. I've built a lot of aero packages, designed a lot of them with CFD programs, complex fluid dynamics. It's not really useful. Like, that's not really a thing. Normally what happens with airflow, the air will hit the front of the car or be above it, go over the hood. That air basically stays attached. You have laminar flow over the top part. It then detaches towards the back glass. That's where wing comes in. And now here's what most people do not know. You'll see all these cars driving around, these aftermarket cars. They throw wings on the back, and I got a wing, and I got an adjustable wing. Yeah, listen. Unless that wing has been designed to work with your diffuser, you're maybe getting 50% usage out of it if you're lucky. The whole point of a wing. So imagine the air coming out of the bottom of the car, okay? So it's coming up, moving up towards the car. It actually wants to curl around. So it's coming up. It's meeting the air coming down off of the trunk of the car. That causes turbulence. That turbulence imagine like a spinning tornado on its side, okay? That's grabbing the back of the car. Imagine putting your hand over a vacuum cleaner, and then you pull and you can feel it kind of trying to pull your hand back. So that's what that spinning tornado on its side is doing. It's trying to pull your car. It's trying to pull your car back. What a wing does is that air that comes over the top that's being disconnected, it's becoming weaker, turbulent flow because it's disconnecting from the body of the car, is now impacting that wing. That wing redirects it back to meet up with wherever your diffuser is also redirecting the air from the bottom side. So your diffuser is bringing the air, say, this way, okay? Your wing is deflecting the air to come this way. They're now mating up way back here at a certain spot, all right? That basically causes a hole in the air directly behind your vehicle. It's moving that air pressure farther away. So it's helping you aerodynamically. It's lowering your drag coefficient, basically making your car go faster. It's the same exact thing that if another car got up right behind you, we all have seen Days of Thunder or something like that, where it's drafting. It's all about drafting. Okay, that's basically kind of what is the same thing. That car is coming up on your backside, all right, and it's making that air continue on past the back of your vehicle so far that it's not affecting your car. So to kind of bring it all back around, I am kind of surprised that AMG decided to do this. I'm sure maybe there's some kind of reason that they did or something. A lot of you guys know I used to work for Daimler Chrysler Viper Racing Division. All right, so I know a fair amount about these cars and engineering them. These guys aren't stupid. They're not morons. Most of them. I'll say that. Most of them. But that being said, maybe, I don't know, maybe it's something they wanted to try, which seems kind of strange in a production vehicle. I've got to assume that there's some kind of reason. That being said, I am kind of surprised. Probably what you would have wanted to do instead, and as a matter of fact, what I'll probably design and build for these AMGs, which, by the way, if you want one of these, give me a call, I'll build you one. But I'll probably end up designing a true flat bottom system. So because what you would have wanted to have was a diffuser, I'm sorry, a front splitter coming off the front, and then doing a step down to a true flat bottom, okay? And you would want all of this truly flat, a true flat bottom. Truth be told, you also want some side skirts if possible, which that's actually what I'm going to be doing to this. I'm actually right about here. I'm going to be doing a turn and bring it out, the exhaust right here, and doing some side skirts for it. That side skirts help immensely with aerodynamics. But anyways, do a true flat bottom as much as you can down this vehicle. Let me make sure I don't crack my head. And then when you get back to about here, you're going to set your angle on your diffuser, okay? And if you look at a diffuser, I'm sure you guys have seen them. If you've seen any of the other ones we've built, you see what looks like winglets coming down off of them. All right, that is to basically tunnel the air. And they should be in a shape. They shouldn't just be straight. If they're just straight, it's kind of useless. What they need to be in is almost like a V, So the air will come into it, and it will start small and will expand out at whatever angle you've set it at. As it's expanding out, it's basically directing it, it's expanding that air and directing it back to where your wing is going to meet up, which is maybe, I don't know if you guys can see, but maybe out here somewhere, way up here. So anyways, that hurt my toe. But anyways, I'm probably going to design that and build one for this. Again, I'm just really surprised. I'm surprised they decided to go with this design. These guys normally are super smart, but I know some F1 teams personally that have attempted to test that out. Hasn't really worked. Again, though, any kind of rotating mass like a wheel for a bicycle or something like that, sure, works great. A static object moving through the air where you're having a pressure differential between the bottom and the top, that's a different animal. But who knows? You know, maybe someone can, you know, design something on these wheels and test them out, see if something like that would help. On the same vein, I do know there's companies out there that they sell wraps. They're basically like little dimples, will makes your stuff look like a golf ball. Don't buy them. No point. Literally no point. I don't care. The only thing those guys have is good marketing. I promise you, I 100% promise you, they do not work. That's not how airflow works. All right. Changing all your laminar flow over to Reka or turbulent flow, that is not something you want. At best, you'll get exactly the same aerodynamic properties and mile per gallon and all that you would have normally. And at worst, you're actually going to lose some. So listen, don't do that. Don't bother with it. But I just wanted to touch on this. I want to talk to you guys about this while I was under here messing with it. If you have any questions, anything like that, or if you would like a flat bottom system built for your vehicle, hit me up. Leave a comment down below. Hope you guys enjoy the video. Y'all take care, and I am DONE done. See ya.